The future is already written, why physics says time is a lie. The mirrors were already aligned when the signal arrived from space. A photon that left Earth minutes ago met a decision we made now, and the interference pattern either appeared or vanished. On the monitor, two images, wave, particle, same photon, different pasts. The lab went quiet. Someone whispered, "So, which story happened?" To understand how a present choice can rewrite a particle's history, we need to go back to the moment time lost its flow. Not in a lab, but on a train, where a patent clerk realized clocks weren't sacred. This is where the future stopped waiting its turn. The moment everything changed. Einstein flattens time. The year is 1905. Albert Einstein is commuting through Bern, turning over a question that never lets go. If you could ride alongside a beam of light, what would you see? He can't sleep it off. He can't file it away. Because the math says something radical. Light speed doesn't change. So something else must give. Here's the thing. Nobody on that train knows yet. If light refuses to budge, time must. Two clocks that agree in one place won't agree in another if they're moving relative to each other. Simultaneity, the idea that now is the same everywhere, breaks. That crack in now becomes a doorway. Get this. Different observers slice the same world into different presents. You're drifting through space on one ship. I'm rushing past on another. We each draw a line across space-time and call it now, but our lines don't match. The present is personal, not universal. Einstein didn't set out to dethrone the present. He just followed light to where it led. A few years later, Hermann Minkowski takes Einstein's insight and gives it geometry. Space and time, he says, aren't separate. They're one four-dimensional fabric, space-time. Events are points in this fabric. Your birth, your first day of school, the decision you'll make 10 years from now, they're all coordinates. From now on, Minkowski says, space by itself and time by itself are doomed to fade away. The room laughs, the laughter fades, the idea doesn't. This is the seed of the block universe. Not a river, but a map. Past, present, and future all laid out. We don't travel through time. We traverse different slices of the same structure. If that sounds cold, it's because we've lived our whole lives inside the feeling of flow. But feelings aren't laws. The math is. What nobody in 1908 can see is how this geometry will haunt every debate about free will, destiny, and meaning. If the future is already there, what becomes of choice? Hold that thought. For now, look at the stakes. If all events are embedded in the block, causality isn't a sequence marching forward. It's a pattern in the fabric. Changing the pattern would mean changing the fabric, and the fabric doesn't change. Meanwhile, the world keeps insisting it feels like it does. We remember backward, not forward. Entropy increases. Coffee cools, never uncools. Eggs scramble. The macroscopic arrow points one way. Einstein shrugs at arrows. The fundamental equations don't pick a direction. Time, at the root, is symmetric. The asymmetry shows up later, in boundary conditions and statistics, not in the bedrock. Here's where it gets uncomfortable. If the block is real, then grief is a cross-section problem. The person you lost isn't gone everywhere in space-time. They're gone in your current slice. But you can't step to another slice at will. The geometry allows, biology denies. That gap between what's there and what we can reach is the human wound. The theory doesn't heal. To see how the block handles cause and effect, consider two lightning strikes hitting opposite ends of a moving train. On the station platform, they're simultaneous. On the train, one arrives first. Whose now wins? Neither. Each observer's slice is legitimate. Causation has to be something both agree on, or it isn't fundamental. Signals inside light cones stay ordered for everyone. That's the anchor. The rest, our sense of simultaneous nows, is negotiable. And that's the doorway quantum mechanics will kick open. Because if simultaneity bends, what keeps before and after straight at the smallest scales? The Schrödinger equation runs time both ways. Wave functions evolve smoothly, whether you flip TTT or not. Decoherence gives us apparent irreversibility, but the math underneath doesn't care. So where does the arrow come from? Not from the laws themselves. From the low entropy past we started in, and from how we as agents make inferences. That's the operational asymmetry. We prepare, then measure. We update beliefs forward because we're stuck moving through slices in one direction. biologically and thermodynamically. Einstein's flattening of time doesn't prove the block universe, but it makes it hard to avoid. In a world where now depends on motion, privileging one universal present is like privileging one longitude. You can do it out. Little toy books. Nature won't back you up. The geometry just sits there, indifferent. Still, there's one problem Minkowski doesn't touch. The quantum experiment that seems to let a measurement today decide whether a photon was a wave yesterday. We'll get to delayed choices and erased paths soon. For the moment, note the alignment. A block universe happily hosts stories where boundaries at both ends matter. If the whole history is a fixed path in space-time, you can specify conditions in the past and in the future. The middle fits both. That's the spirit of time-symmetric quantum ideas. Two boundary conditions, one consistent story. Back on that burn train, the clerk finally steps onto the platform. He doesn't know he's flat in time. He only knows the equations work, and the postman needs his signature. Years later, we give his insight a name that sounds like philosophy, but came from clocks: Eternalism. The future isn't waiting to be written, it's part of the book. We turn pages. The pages don't appear because we turn them. Here's the quiet twist. If the book is written, we still have to read it. Choice in this geometry is the page on which your decision lives. It's real where it is. Your deliberation, your doubt, your yes or no, all located, all part of the block. Determinism doesn't erase the feeling, it contextualizes it. And the science that began with the stubborn speed of light will soon meet photons that act like they've read ahead. The quantum rebellion arrives. The rebellion doesn't start with lasers or paradoxes. It starts with a lab bench, a darkened room, and a beam splitter. A single photon hits a crystal and, this is the first insult to common sense, behaves like a spread of possibilities. Not a tiny marble taking one path or the other, but a wave that explores both. You set up an interferometer, and if nothing marks which path it took, you get fringes. Bright, dark, bright. Ask which path, the fringes vanish. The act of asking changes the story told by the outcomes. Here's where the revolt gets teeth. The Schrödinger equation evolves that wave function smoothly in time. No built-in arrow. It's us who add an arrow when we prepare a state and then measure it. Operationally, we look forward. Mathematically, the equations don't care. This gap is small on paper. In experiments, it yawns. 3 days earlier, someone in Vienna has an idea that goes back to Wheeler. What if you delay the choice? Let the photon commit to the interferometer. Then after it's inside, decide whether to close the second beam splitter. If it's in, paths recombine and make interference. If it's out, the paths stay separate and carry which path information. Wheeler says, make that decision late. So late, it looks like the future sets the past. Decades later, teams actually do it. Single photons, fast switching, random choices. The data don't blink. Choose to erase which path information, and you recover interference. Choose to reveal it, and fringes disappear. The choice happens after the photon enters, sometimes after it's detected at one arm. The pattern still lines up with the later choice. Now remember, none of this sends signals to the past. No lottery numbers get whispered to yesterday. But the correlations are brutal. It's as if the story of the photon's past is only settled when present boundary conditions lock in. In a block universe, that's not witchcraft, it's geometry. You're picking a slice that fits both ends. Get this, researchers push the separation. They create entangled photon pairs in the Scully-Drew quantum eraser setup. One photon, the signal, heads to a screen. Its twin, the idler, carries which path tags. Depending on how you measure the idler, you can sort the already recorded signal hits into two piles. In one pile, a fringe appears. In the other, it vanishes. The hits were always there. How you choose to read them decides whether you see wave or particle behavior. When the idler choice is space-like separated, no time for light to carry influence, the correlations still hold. Meanwhile, across town, theorists sharpen a time-symmetric knife. The two-state vector formalism says a quantum system is described by two states. One evolving from the past, one evolving backward from the future. Pre- and post-selection. You specify what you prepared and what you'll later find. Between those, weak measurements reveal odd, context-dependent weak values. It's a language made for a block. Initial and final boundary conditions pin a single, consistent middle. No particles sending messages to yesterday, just a history constrained from both directions. What nobody knew at first is how far you can push causal order itself. In quantum information labs, the order of operations goes into superposition. Process matrices and the quantum switch let A happen before B and B before A, neither fixed, both contributing. No paradox, but a warning. Causality, as we use it, is a resource that can be bent. If order can blur, holding tight to a single temporal narrative is a choice, not a law. These experiments match the indefinite causal order framework in quantum information theory. This is the moment everything changes in our story. The delayed choice and eraser experiments don't prove retrocausality. They invite it as one clean explanation among others. You can stay Copenhagen and say nothing exists until measured. You can go many worlds and say both outcomes happen in branching histories, so no need for backward arrows. Or you can keep time-symmetric and let future boundary conditions be as real as past ones. Different philosophies, same statistics, but the human stakes are different. Each picture tells you something about what a decision is. In the aftermath, skeptics try to tame the eraser. They point out there's no way to use it for messaging, that apparent retrocausality is an illusion arising from post-selection. Fair. The math of conditional probabilities is unforgiving, yet the structure keeps nudging. When you condition on a future outcome, past ensembles reorganize into patterns that look like choices, reaching back. If you're living in a block, of course they do. The book has both ends printed. Meanwhile, Thermodynamics watches from the door. At macro scales, entropy rises, records accumulate, and arrows harden. Decoherence explains why quantum superpositions leak into environments and become effectively classical. That's why you can't do an eraser with your coffee cup. The cost of erasing would be astronomical. But at the scale of single quanta, where phase can be protected, you can thread pathways that make our intuitions wobble. So here's our position. The quantum rebellion doesn't overthrow relativity's geometry, it moves in. It lives comfortably in a space-time where now is personal, where laws are time-symmetric, and where boundary conditions matter. It flips the question from what did the photon do, to what story fits both ends of this experiment. And as the stories get stranger, post-selection, indefinite order, entangled histories, the block starts to feel less like a cold map and more like a script with constraints on the first and last scenes. The middle plays accordingly. Delayed choice to pass waits for you. 3 days earlier, a graduate student taped a note above a switch. Don't blink. The setup was simple on paper, brutal in timing. A single photon source fired into an interferometer. One arm longer than the other, both leading to a place where a second beam splitter might or might not be there when the photon arrived. The decision to insert it wouldn't be made until after the photon had already entered the device. That was the dare. Let the present decide how the past looks. The stakes here aren't abstract. If wave or particle depends on measurement, fine. That's quantum's usual sting. But if your choice now aligns with a pattern that seems to require a choice, then you've pushed on causality's ribs. You're not sending a message back, but you are finding that the story you tell about what happened depends on a knob you turn late, for people who build their lives on before and after. Pilots, surgeons, parents. That's not a puzzle, that's vertigo. Action first. The photon leaves the source and hits the first beam splitter, its wave function branching into two paths. In the closed configuration, a second beam splitter recombines the paths and interference emerges. Certain detectors click more often, others less, depending on phase. In the open configuration, that last beam splitter is removed, the paths don't recombine, and you get which path information. No fringes, just particle-like clicks. Wheeler's twist was timing. Use a fast random number generator to decide open or closed after the photon is already en route. Even stretch it. Make that decision so late it's space-like separated from the photon's entry. No light speed signal could warn the interferometer what to be. Impact hits in the data. When the choice lands on closed, the statistics show interference. When it lands on open, the statistics show no fringe. The late choice correlates with the early behavior as if the photon took both paths or picked one depending on what you decided after it committed to the apparatus. Jacques and colleagues ran that play with single photons and high-speed modulators. Ma and Zeilinger pushed it to cosmic scales, using starlight to seed the randomness that decided the setting. So the decision originated years away. The numbers stayed loyal. The pattern matched the later choice. Meanwhile, something else was happening across the hall. People were trying to kill the romance. They pointed out that there's no paradox if you tell the story carefully. You never change a recorded outcome. You only sort outcomes into sub-ensembles conditioned on the later setting. That's statistics, not time travel. True, but the sting remains. The most economical narrative in a time-symmetric, block-like picture is that. Boundary conditions at both ends shape the middle. You can refuse that language and still compute. the discomfort doesn't go away, it just moves. Here's the moment everything changes for the characters in this lab. That note, don't blink, wasn't about attention, it was about agency. They were watching their own choices knit into the description of what had already happened. The switch flips, a run completes, and later, when they plot the counts, the fringe is either there or it isn't. The past they reconstruct isn't a neutral archive. It's a story that depends on how they close it out. Stakes again. If delayed choice holds in clean, protected systems, what fences it out of daily life? Thermodynamics. Decoherence. The environment is nosy. It leaks which path information everywhere. By the time you try to decide late about your coffee, the universe has already measured it 1 trillion times. The arrow hardens. But the lab gives you a sanctuary where phase survives long enough to stage this argument with time. Action escalates with the quantum eraser variant. Now the signal photon hits a detector screen long before its entangled twin, the idler, reaches the choice apparatus. The idler carries which path tags. Depending on how you measure it, erase the tags, or read them, you can later sort the already stored signal hits into 2 piles. One that shows interference fringes, one that doesn't. Nobody changes any pixel on the hard drive. You just learn which subset belonged to a wave-like history and which didn't. When the idler choice is made so late that no signal can fly from that station to the earlier screen in time, the correlations still assemble. The lab goes quiet, not because they solved anything, but because the screen, in hindsight, looks like it was waiting to be told which past to reveal. Impact widens outside physics. If the block universe is right, the delayed choice experiments don't break causality. They illustrate consistency. You specify initial and final conditions, and the history in between fits both. Two-state vector folks nod time-symmetric boundary conditions. Transactional interpretation fans talk about advanced and retarded waves forming a handshake. Copenhagen replies, "Stop asking about what really happened between preparation and detection. Many world shrugs, all paths exist in branches, you're just seeing which branch you rode." But the human angle won't sit down. A parent rewatches an ultrasound after a diagnosis and feels the past shift under the present's weight. A historian uncovers a letter and the meaning of a battle changes. Those aren't quantum effects, they're cognitive, memory reconsolidation and narrative reframing in the brain, not physical retrocausality. Still, the structure rhymes. What you learn now reorganizes the pattern you tell about then. In quantum labs, it's not just a story, it's statistics on a screen. So what do we do with this? We admit the limit. No retro messages, no fixing yesterday. We accept the power. Present settings select which lawful narrative of the past we're licensed to tell. And we keep building experiments that stretch the separation, close loopholes, and swap human caprice for cosmic randomness. If the past seems to wait for us in these chambers, maybe it's because, in a block universe, the past and the future are neighbors on the same street. We're just learning the address system. Quantum eraser, unmaking, which path after the fact. Here's where the experiment stops being polite. We don't just delay the choice, we outsource it to a twin. The Scully-Drool quantum eraser takes an entangled pair, signal and idler, and marks which path on the idler while letting the signal race to a screen. The insult is surgical. The signal hits, the pixels are saved, and only later do we decide whether the idler's path tags get read or erased. The hard drive is already cold. The choice is still warm. Stakes first. If the lab can sort yesterday's dots into wave-like and particle-like piles using a decision made now, that's not just weird. It rubs our thumb across causality's grain. You can't alter the raw image, you can alter the meaning. The difference sounds semantic until you're the one plotting the counts and watching a fringe appear where there was none, just by changing how you label the subset. That relabeling feels like a small thing. It isn't. It's the fault line between narrative and event. Action on the table. A nonlinear crystal spits out entangled photons. The signal photon flies straight to a detector screen, building a broad, blur-like distribution that by itself shows no interference. Meanwhile, the idler takes a longer forked path with beam splitters and polarizers that either preserve which path information or erase it by recombining indistinguishable alternatives. Detectors at the idler station are wired to different fates. Some keep the path tags, some scramble them. You don't look at the signal screen and see stripes. You look after. The run, correlate each signal hit with the idler's detector, and then, only then, two very different stories emerge. The subset matched to erased idler clicks lines up in a clean interference pattern. The subset paired with which path kept refuses to fringe. Impact lands with timing. In clever versions, the idler's path is long enough that the signal has been recorded long before the idler gets measured. Space-like separations close the usual loopholes, no faster than light whispers. Yet when you sift the data by the later idler outcomes, the past screen reorganizes into order or into noise. The pixels didn't move, the pattern did in hindsight. Critics call it post-selection dressed up as magic. The teams call it quantum mechanics doing what it always does. Correlations that only show their face when you ask the right joint question. Meanwhile, something else is happening. Interpretations collide. The Copenhagen camp says, don't talk about unobserved paths. The joint measurement outcomes are the only facts. Many World says, both erased and kept branches exist. You're just conditioning on the branch you occupy. Time-symmetric folks nod, pre- and post-selection define the middle. Two-state vector formalism was built for exactly this. And the transactional interpretation sketches its handshake. Advanced and retarded waves forming a transaction that spans emitter and absorber. Different languages, same counts. But the block universe lens makes one thing feel almost calm. Both the early screen and the late choice are points in the same four-dimensional story. Fix both, and the consistent history in between comes along for the ride. Stakes sharpen when labs push harder. Experiments implement quantum erasure with causally disconnected choice, making the idler choice outside the signal's light cone. Others use cosmic sources to randomize the setting, reaching back years for the seed that decides whether which path is kept. Aspect's lineage of entanglement tests, Jacques' delayed choice setups, and Mazilinger's cosmic choices close doors one by one. No hidden signal sneaks through. The structure survives. Erase indistinguishability constraints, get interference. Mark paths, lose it. The order of asking doesn't rescue you. Action zooms to the human moment. A grad student watches the sifting code run. Two plots bloom on the screen. One looks like rain on asphalt, flat. The other breeze, bright, dark, bright. She didn't change a single pixel in the raw. She changed the question, which subset goes together? That's the micro story of every eraser. You don't revise events, you revise ensembles. In statistics, that's ordinary. In your gut, it feels like the past waiting to hear what you'll care about. Impact echoes far beyond lasers. If causality were a strict arrow, future conditions couldn't shade the description of earlier results. In a block, causality becomes consistency across slices. The no-signaling theorem keeps you honest. You can't send a message to your previous self. Thermodynamics keeps you grounded. Macroscopic erasers are fantasy because the environment has already measured everything. But within protected islands of coherence, the universe lets you stage a rehearsal for a bigger question. Is time's order a property of the world or a property of the stories we tell to navigate it? Here's the quiet kicker. Even if you hate retrocausality, the eraser forces an admission. The meaning of what happened between preparation and detection isn't a standalone fact. It's relational, pinned to both ends of the experiment. That's the block universe in lab clothes. You specify boundary conditions, and the middle obeys. The past isn't rewritten, it's revealed through the lens of a later choice that was always in the script. Retrocausal temptation. Can effects precede causes? Get this. Once you've watched fringes appear in hindsight, the next question shows up uninvited. Can an effect ever sneak ahead of its cause? Not in the way movies sell it. Nobody is texting yesterday. But there's a real temptation here, because quantum theory keeps rewarding stories that use both past and future to explain the middle. If the world is a block, maybe because then effect is just one way to read a fixed page. Start with the cleanest case, time-symmetric quantum mechanics. The two-state vector formalism treats every quantum system as guided by two boundary conditions, what you prepared and what you later found. Between those, you can perform weak measurements that reveal weak values, numbers that depend on both ends. Call it retrocausal if you like, it's really constraint satisfaction. The final measurement doesn't reach back to change anything. It narrows which middle histories were ever on the table. Meanwhile, the transactional interpretation runs the same play with different words. An emitter sends an offer wave forward in time. An absorber sends a confirmation wave backward. Where the two meet, a transaction forms, Kramer's handshake. Nothing superluminal, nothing paradoxical. The handshake spans the whole light path, from source to detector as one atemporal deal. If you're living in a block universe, that's just how space-time business gets done. But there's a problem. Language inflates quickly. Say backward in time influence, and it sounds like causation has reversed. The experiments won't cash that check. Delayed choice, erasers, even quantum switches with indefinite causal order all respect no signaling. You can't control a future outcome enough to encode a message for the past. Thermodynamics sits behind that guarantee. To send a stable bit back, you'd need to systematically bias outcomes while fighting noise and entropy. The statistics won't give you that lever. Still, the temptation isn't silly. It's strategic. Retrocausal models promise to explain entanglement without spooky action at a distance. Instead of a non-local jab across space, you let correlations form, because both particles share future boundary conditions at their detectors. They meet again in the future, so their earlier states are correlated. Sutherland and others have sketched models in ordinary three-dimensional space that try to pull this off, keeping locality by letting influences run both ways in time. The math can be elegant, the jury's out on whether it earns extra predictive power. Here's the human moment. In the lab, a student watches post-selection carve a nonsense cloud into two crisp pictures. It feels like the future is tugging on the past. Later, in a different building, someone reads a diagnosis and feels an old memory tilt. That second scene isn't physics. It's psychology, where the brain rewrites stories as new information arrives through memory reconsolidation and cognitive reframing. But the rhyme is strong enough to seduce us. We confuse narrative revision with physical revision. The experiments warn against that. No pixel changes, only the sub-ensembles do. What nobody knew early on is how far the order can blur. Processes with indefinite causal order let you put A before B and B before A into superposition. Run both orders, interfere them, and outperform fixed-order circuits on certain tasks. It's not retrocausality, but it's a proof that cause and effect is a resource you can engineer rather than a background rule. If order is flexible in the micro-world, using future constraints to talk about present statistics stops sounding mystical. It sounds efficient. Critics push back with a fair question. If retrocausal talk buys no new predictions, why use it? Because it can lower the metaphysical bill. You trade non-local influences for bidirectional constraints inside a fixed spacetime. For block universe thinkers, that's tidy. For others, it's lipstick on the same mystery. Copenhagen says drop the story, keep the algorithm. Many World says branching avoids both non-locality and backward arrows. Every outcome happens, and correlations are just bookkeeping across branches. Meanwhile, entropy keeps the peace. The arrow we live by, memories behind, openness ahead, comes from low entropy beginnings and relentless decoherence. That's why retrocausal flirtations stay microscopic. The environment is a gossip. It records everything. Try to erase at scale, and the world shrugs. Too many copies of which path have leaked. So where do we land? Effects don't outrun causes in any controllable way, but the most economical stories for quantum experiments inside a block universe often let future boundary conditions co-author the present. If that sounds like cheating, remember the deal we made in Act Twins. In space-time, before and after are slice-dependent. Consistency, not push and pull, holds the script together. We aren't changing the past. We're
learning which past was ever consistent with the future we actually got. Many worlds versus block world. Meanwhile, a different escape hatch sits across the hall, covered in chalk dust and confidence. Many worlds, where retrocausal talk uses future constraints. Everett's idea says don't constrain. Branch. No collapse, no special measurements, just the Schrödinger equation all the way down. When a quantum event has multiple possible outcomes, the universal wave function splits into non-interacting branches where each outcome happens. You never see the splits, you live inside one. Here's why it appeals after delayed choice and erasers. Instead of saying the present helps pick a consistent past, Many Worlds says every consistent past-future pairing exists somewhere in the branching structure. The erased subensemble and the which path subensemble aren't selected late. They're different branches that were always there. You're only ever aware of one because branches don't talk. No signals, no paradox, no handshakes across time, just parallel histories. From the block universe seat, that's not a contradiction. It's a layering. Take Minkowski's 4D map and thicken it. Not one block, but a branching forest of blocks embedded in a larger structure. Each branch is its own fixed space-time history. Inside any branch, past, present, and future are equally real. Eternalism holds locally. Across branches, there's multiplicity instead of collapse. So the question becomes simpler and harder at once. Are we living in one block or a multiverse of blocks? Stakes first.
Many worlds promises to save locality. No spooky action, no backward influence. Entanglement correlations arise because the wave function's branching structure locks outcomes together at the moment of interaction. But it asks you to buy an ontological skyscraper. Staggeringly, many realized histories, most unobservable to you. The block view asks you to buy a frozen page. Everett asks you to buy a library. Action in the lab won't decide it. Both pictures reproduce the same statistics. In a quantum eraser run, a many-world story goes like this. The joint system evolves unitarily. Detectors become entangled with idlers. The lab splits into branches where idler settings correspond to interference or no interference in the correlated subsets. You, as an observer, entangle with one branch and later sort data accordingly. No retrocausality, just conditional awareness in a particular branch. In a block story, you'd emphasize boundary conditions, fixing a single history. Both are clean. Both are costly in different currencies. Impact shows up in human terms. The block world sharpens determinism. Your choices and regrets are coordinates on a single path. Many worlds softens it by distribution. For each choice you make here, there are branches where you didn't. Comforting? Not really. The you watching this only rides one branch. The others don't send comfort. The sense of, I could have done otherwise, becomes a version of me did otherwise, which doesn't help when you need to own what happened in this line of life. Meanwhile, decoherence plays referee. It explains why branches don't interfere at macro scales. The environment records which branch you're in by scattering information everywhere, making cross-branch interference effectively impossible. That's why your coffee doesn't recohere. In the block view, decoherence picks out classical-looking histories inside the fixed structure. In many worlds, it creates the branching you live through. Same math, different metaphors. What nobody mentions loudly is operational asymmetry, the way we use the theory. We prepare, then measure. We update beliefs forward. Many worlds claims no special update. You just find yourself in one outcome. The block view says updates are epistemic. You're revealing which fixed page you're on. Neither changes the counts on the screen. Both change the story you tell yourself later. Here's the moment everything changes for our narrative. We don't need a winner to move on. The delayed choice and eraser experiments force us to accept that the meaning of what happened hangs on how you frame the entire experiment, not just its start. Many worlds handles that by multiplying frames into branches. The block handles it by letting initial and final frames co-author one story. If you care about parsimony, you'll ask which picture spends fewer assumptions. If you care about locality, you'll reach for branches. If you care about a single world with time-symmetric laws, you'll favor blocks with two boundaries. In the aftermath, the practical rule survives untouched. No signaling, arrows from low entropy, decoherence everywhere. But the choice of story matters for how we live with time. The block invites acceptance. What is across the page. Many worlds invites humility. Reality may be wider than the slice you see. Either way, the lab results keep pointing to the same quiet fact. Our present is not the whole story.
And causality, as we feel it, is a local habit inside a larger, stranger order. Relational and block interpretations. While the many worlds chalkboard's cool, another door slides open. Quieter, but sharp. Relational views ask a blunt question. What if facts don't exist? From nowhere? What if every statement about a system is about its relation to something else? That's not hand-waving. It's a way to shrink what needs explaining. Instead of a universal absolute state, you get states relative to observers and devices. And in a world where now is slice-dependent, relativity already warned us. Vantage points matter. Here's the stakes. If facts are relational, then the block universe doesn't need to carry labels like wave or particle on events by themselves. Those labels belong to the stories told by specific interactions. The block holds every interaction. The relations live on its threads. That's less mystical than it sounds. Your height is relational to a ruler. Your speed is relational to a frame. Quantum properties may be no different. Action in the lab makes this concrete. In a delayed choice run, the photon isn't really a wave or really a particle, full stop. Relative to the closed interferometer, it's wave-like, because the device sets up a relation that supports interference. Relative to the open configuration, it's particle-like because the relation preserves which path. In the quantum eraser, the signal screen and idler station don't trade messages. They define a joint relation that only shows up when you compare notes. The fringe appears in the subset defined by that relation. No subset, no fringe. The property isn't stored in the photon like a baseball card. It's minted by the relation.
Meanwhile, time-symmetric programs fit right in. Two-state vector formalism is relational backwards and forwards. The system's weak values are defined relative to pre- and post-selection, relations to the past and to the future. In a block picture, those relations are just lines drawn between fixed events. The middle doesn't need a hidden mechanism reaching back. It needs the right bridges between boundaries. What nobody tells you early is that this move changes the burden on reality. In a strict block, it's tempting to treat every event as having a complete set of intrinsic properties. Relational views say, careful. The event has coordinates and connections. The properties we report, position, momentum, polarization, are answers to questions asked by specific apparatuses. Change the apparatus, change the relation, change the answer. The block carries all the questions and all the answers tied together. Stakes again, but human this time. If properties are relational, your choices aren't downgraded, they're located. The decision to insert the beam splitter isn't an illusion. It's the act that defines which relation becomes real in your slice. In the block, that moment is a point with consequences drawn both ways along the network of relations. You didn't bend the past, you fixed which network you inhabit. Responsibility survives. Fatalism doesn't get a free pass. Action broadens in cutting-edge labs playing with indefinite causal order. When A before B and B before A go into superposition, what's the order? Relationally, order is a property of how operations compare, not a universal feature stamped on the world. The quantum switch doesn't say time broke. It says order is a relation that can be engineered and put into interference when protected from decoherence. Again, the block can host such processes as complex atemporal diagrams. The before and after labels attach when agents read off results along their world lines. Impact lands on the old arrow question. If the asymmetry we feel comes from boundary conditions and the way we as agents process information, then relational stories help explain why operational time looks one way. We prepare relative to our past, we measure relative to our future, and decoherence floods the environment with records that privilege that direction for beings like us. The block stays time-symmetric underneath. The web of relations we participate in is not. Meanwhile, interpretations square off without shouting. Copenhagen says the only meaningful statements are about outcomes relative to setups. Relational quantum mechanics sharpens that. Even different observers can hold different, consistent accounts until they compare. Then a new relation forms. The transactional interpretation relabels relations as handshakes across space-time. Two-state vector ties relations to both ends. The block doesn't choose a camp. It supplies the stage where any relational script can run without contradiction. Here's where everything tilts toward clarity. When you hear time is an illusion, it's easy to think the block erases experience. Relational and block together argue the opposite. Your experience is a set of real relations, neural, environmental, social, anchored to a location in space-time.
The flow you feel is the brain updating models as new relations lock in. The grief you carry is a relation to events you can't re-enter. The meaning you find is a relation to choices fixed on your world line. None of that is fake. It's local, perspectival, and fully housed inside a bigger atemporal structure. So the lab takeaway becomes a life takeaway. Stop asking what a system is in isolation. Ask what it is relative to the questions you can actually ask and the boundaries you can actually set. In that frame, delayed choice isn't a ghost of the future. It's a reminder that meaning in physics and in life arrives when relations close the loop. Bell tests and no-go theorems. While the eraser crowds argued over stories, a harder judge was setting up across the corridor, John Bell. Bell didn't write essays, he wrote inequalities. If hidden variables were quietly deciding outcomes behind the scenes, they had to obey limits any local, cause-forward world would respect. Violate those limits, and you've cornered reality. Either influences aren't local, or outcomes aren't set in the way you thought, or time's order isn't what it seems. The block universe doesn't flinch at that trilemma. It's built to host constraints that stretch across space and time. But Bell's tests force you to choose a cost you're willing to pay. Here are the stakes. Bell's theorem isn't about gadgets, it's about the price of realism and locality. If measurement results exist with definite values before we look and no influence outruns light,
then certain combinations of correlations must stay within a bound. That bound isn't metaphysics, it's arithmetic. Break it, and at least one cherished assumption has to go. For engineers of intuition, this is the moment the floor gets pulled. Action first. Aspect, Dalibard, and Roger in the 1980s switch polarizer settings while entangled photons are already in flight. They see correlations that beat Bell's local bound. Skeptics point to loopholes. Maybe the sample was biased. Maybe the detectors missed too many events. Maybe the settings weren't really free. Decades of experiments slam those doors. High-efficiency detectors close the detection loophole. Rapid random setting choices close the locality loophole. Cosmic sources generate the randomness years away, bending shut the freedom of choice loophole by pushing any conspiracy back into starlight. Each time, the data sing the same note. Quantum predictions win. Bell inequalities lose. Impact lands sharp, local hidden variables. The hope that outcomes were tucked into the particles like secret instructions are off the table. You can keep locality by dropping the idea that outcomes exist before measurement, or keep realism by letting some kind of influence stitch space-like events into a joint story. Or you can keep both and let causality flex in time, accepting retrocausal constraints that run backward inside a block. Different routes, same crossroads. Meanwhile, something else is happening in the fine print. No signaling still stands. However wild the correlations, you can't code a bit into your setting choice and have your partner read it off instantly. That's the guardrail. It tells you Bell violations aren't about usable faster-than-light messages. They're about global consistency that outruns any piecemeal local account. In the block picture, that's natural. The joint outcomes are a single, four-dimensional fact pattern. Slice it anyway, and the pieces fit because the whole is fixed. This was the moment everything changed philosophically. Bell stripped away interpretive wiggle room. Before, you could shrug at delayed choice and say, interpretation. After Bell, you face a theorem. Local realism can't be the world's wiring. Copenhagen leans into non-committal talk. Outcomes don't pre-exist, and questions define answers. Many worlds keeps locality by expanding ontology. Branching eliminates collapse, and correlations come from a shared past unitary evolution. Time-symmetric and transactional camps offer a different payment plan. Keep locality in space by allowing boundary conditions in time to do the gluing. None of these pictures let you have the old comfort of local Beebles with pre-assigned results. Bell burned that bridge. Stakes rise with no-go theorems around the edges. Kochen, Specker, rules out non-contextual hidden variables. You can't assign outcome values independent of which other compatible measurements you perform. Pusey, Barrett Rudolph argues the quantum state can't be just knowledge about a deeper reality unless you stomach awkward conspiracies. The wave function looks real on pain of contradiction. Frotchiger. Renner challenges single-world consistency when different observers reason about each other's measurements. Each result tightens the net. Simple pictures that stash uncertainty and ignorance, or that keep facts independent of context, crack under pressure. Action returns to the lab with device-independent protocols. Because Bell, violations are so robust, you can certify randomness and security without trusting the inner workings of your devices. Device-independent randomness generation and QKD. That's a practical dividend of quantum correlations. In a block view, it doubles as a parable. The constraints aren't local recipes. They're global consistencies you can leverage without peeking inside the black boxes. The whole fixes the parts so strongly that you can make guarantees from correlations alone. Impact again on causality. Process matrix experiments with indefinite causal order don't violate Bell, but they rhyme with its lesson. Our classical ideas about before and after, about independent local properties, aren't sacred. Operational asymmetry, prepare then measure, doesn't come from the laws. It comes from agents embedded in a thermodynamic world. Bell adds the kicker. Even if you relax the arrow, locality, and pre-existing values can't both survive. Something gives. Here's the quiet synthesis with our story so far. The block universe isn't a verdict about mechanisms. It's a stage that accommodates whatever global constraints reality demands. Bell shows those constraints outrun local, forward-only narratives. Time-symmetric accounts say, fine, let the constraints run both ways. Many worlds says, fine, let the constraints live in an expanded, unitary tapestry. Copenhagen says, fine, stop asking for constraints you can't operationalize. All three honor no signaling and the thermodynamic arrow we live by. None gives you back a world where what happened is a list of local facts set beforehand. So what do we carry forward? Bell tests crush the hope that quantum weirdness is just ignorance about hidden dice rolled at the source. The universe either correlates space-like events through a global atemporal order, or it multiplies histories, so every correlation has a branch-wise bookkeeper, or it denies the question of what was until measurement pins it. In every case, the present isn't sovereign, and the past isn't a standalone archive. They're pages that only make sense bound into the same book. Superdeterminism, the conspiracy option. While Bell was closing doors, a stubborn idea kept its foot in the frame. What if nothing is truly free to vary? Not your random number generator, not the photons, not even your choice of setting. That's superdeterminism, the claim that the variables deciding outcomes and the variables deciding your free settings are correlated by a common cause in the past. No spooky action, no retrocausality, just a universe where the dice in the gambler's hand were carved from the same tree long before anyone sat at the table. Here are the stakes. Bell tests assume measurement independence, the freedom to choose settings uncorrelated with hidden variables. Drop that, and Bell's inequality no longer binds you. You can keep locality and definite outcomes by letting the world conspire, so that whenever you pick a setting, the particles already know how to match it. It rescues a classical picture at a serious price. Every coin flip, cosmic photon, and human decision that seeds a setting is woven into a deep correlation with the system being measured. Freedom becomes a convenient story the block tells itself. Action first, then cost. Then cost. Experiments pushed hard on the freedom of choice loophole. Ma and Zeilinger pulled random bits from starlight that began its journey years ago to choose analyzer orientations. Others use quasars, billions of light years away. If the settings are correlated with the particles, that conspiracy had to start before those photons set out. Superdeterminism shrugs. Fine. In a fully deterministic, block-like space-time, everything shares a common origin. Correlations spread with the universe's very initial conditions. What looks wild from our perspective is just consistency across the page. Meanwhile, something else is happening in the theory shop. A few physicists try to turn superdeterminism from a slogan into a model. The goal? Write dynamics that reproduce quantum statistics without nonlocality, by letting hidden variables include the measurement apparatus and the agent's choice mechanism. If you can calculate those correlations, you can explain Bell violations with local causes. If you can't, conspiracy remains a label, not a theory. That's the practical burden, predictive detail or its metaphysics in a lab coat. Here's the moment it bites human nerves. Superdeterminism doesn't just challenge free choice in experiments, it steps into personal life. If every choice you make is fixed by initial conditions, are you responsible? In a block universe, we already accepted that your decision is a coordinate on a fixed world line. Superdeterminism doubles down. Not only is the page written, the ink that writes your values and the ink that writes the data share the same quill. For some, that's tidy. No mystery channels, no backward influence. For others, it feels like the universe stacked a deck and then asked you to applaud the trick. Impact on science culture is real. Physics relies on randomized trials and independent controls. If deep correlations infect every random source, what does it mean to test a theory? The usual answer is pragmatic. Unless superdeterminism offers a concrete mechanism for those correlations, the methodology stands. You trust cosmic RNGs, not because you worship freedom, but because you've pushed possible common causes beyond any plausible local link. If someone claims the link reaches to the Big Bang, they owe a model that predicts new patterns we can check. Meanwhile, the thermodynamic arrow reappears. Our sense of agency flows from information processing in open systems far from equilibrium. We prepare, then measure, because we remember the past and not the future. Superdeterminism doesn't change that operational asymmetry. It only insists the preparation choices and measured systems are entangled by history before they meet. In a block picture, that's easy to draw. Two world lines that share an ancient ancestor and converge in a lab. Critics raise a clean objection: unfalsifiability. If any correlation can be blamed on initial conditions, what could ever count against the view? The reply is to build a constructive theory that narrows which correlations are allowed, making riskier bets than quantum mechanics. Without that, superdeterminism is a catch-all. With it, it might become a leaner account. Fewer ontological costs than many worlds, fewer temporal acrobatics than retrocausal models, and no non-locality. Here's the quieter synthesis with our story. The block universe doesn't care whether constraints run by advanced waves, by branching, or by ancient common causes. It hosts any global pattern that preserves no signaling and the statistics on the screen. Superdeterminism is the most austere option. One block, one script with every knob, twist, and detector click co-written from the start. If you can live with that, you get locality and determinism back. If you can't, you'll pay elsewhere. In multiple worlds, in time-symmetric
boundary conditions, or in Copenhagen's refusal to say more than we can test. So where do we land? Superdeterminism is the conspiracy option, not because it posits malice, but because it hides the coordination where we can't audit it. In the common past of everything, it could be right. If it is, the lab's hardest-won freedoms are appearances on a fixed stage. The work ahead is simple to say and hard to do. Either turn the conspiracy into equations that risk being wrong, or accept that the cleaner stories still cost less. Time-symmetric physics, a universe with two ends. To understand why delayed choice feels so natural inside a block, we need a language that treats yesterday and tomorrow as equal citizens. Time-symmetric physics gives you that language. The core equations, Schrödinger, Maxwell, even much of quantum field theory, don't care which way you run the clock. Flip T to T. The evolution tracks back like a film rewound. The asymmetry we live by shows up later, in boundary conditions and in the way agents like us handle information. Here's the move. Instead of telling the story with just an initial state evolving forward, you specify two ends. One at the start, what you prepared, one at the finish, what you later found. Between them sits a corridor of allowed middles. That's the two-state vector formalism in plain clothes. A forward-evolving state from the past and a backward-evolving state from the future co-describe the system. Weak measurements, taken gently between those endpoints, pick up weak values that depend on both. It isn't telepathy from tomorrow. It's a constraint problem. When both ends are fixed, the middle stops being vague. That rhythm is exactly what our lab stories keep humming. In the quantum eraser, you prepare an entangled pair, later measure the idler one way or another, and only then do the signal hits sort into fringe or no fringe. In TSVF terms, the backward-evolving state from the idler detector meets the forward-evolving state from the source and shapes which intermediate properties make statistical sense. No signal goes upstream. The atemporal bookkeeping shrinks the set of viable microhistories to the ones consistent with both ends. A cousin to this is the transactional interpretation. It swaps vectors for waves that travel both ways in time, an offer wave from the emitter, a confirmation wave from the absorber. Where they handshake, a transaction forms, a full path from source to detector settled as a single deal across space-time. You don't watch a cause chase an effect, you watch a global match settle. Again, it's a block-friendly picture. The whole path is a fact, not a sequence of nudges. Meanwhile, quantum information is busy showing that even causal order can go soft. In processes with indefinite causal order, operations A and B sit in superposition of A before B and B before A. You can exploit that to outperform fixed-order circuits on certain tasks. Time-symmetric thinking takes this in stride. If causality is a relational resource, not a background axis, then order becomes another boundary-like condition you can set, superpose, and erase inside protected experiments. Decoherence keeps that circus microscopic. The environment slams order into place at human scales. The big objection arrives fast. If the laws are symmetric, why don't we remember the future? Because symmetry of equations doesn't mean symmetry of states. The universe started in a state of remarkably low entropy. That special boundary conditions the direction of information flow. Records accumulate forward, not backward. Add decoherence. Quantum phases leaking into untrackable environments, and you get effective irreversibility. Operationally, we prepare then measure. We compress data from past to present, and rarely the other way. That's the agent's arrow, not the laws. Philosophers press on meaning. If both ends matter, where's freedom? In a block, your choice is a fixed event. In a two-boundary account, it's also a boundary that helps select the consistent middle. Your deliberation, your decision, your hand on the switch, all real, all part of the constraints that knit the history. Determinism doesn't delete decision, it locates it. You're a boundary condition for your world line. This is where time-symmetric physics and the block universe shake hands. In relativity, now is a slice, not a stage manager. In quantum mechanics, the math welcomes constraints from both temporal directions. Put them together, and you get a picture where global consistency replaces stepwise push. Bell's theorem already warned that local, forward-only stories can't carry the correlations we see. Time-symmetric accounts pay with bidirectional constraints instead of non-local signals or multiplying worlds. There's discipline here. No signaling to the past, no paradox loops, no free computational lunch. Retrocausal talk buys nothing operational you couldn't get with standard quantum rules.
Its value is conceptual.
Economy. If the world is a four-dimensional whole, then letting future facts help shape present statistics is not mysticism. It's housekeeping. So we circle back to the lab's quiet shock. The fringe that appears in hindsight wasn't summoned. It was licensed by two ends of a single experiment. Time-symmetric physics doesn't make the past malleable. It makes the story honest. What you prepare, what you later read, and the web between them are one object. In that object, the past isn't over. It's part of a pattern that includes you. Memory, identity, and grief in a block universe. Here's the human bill for everything we've just said. So does the last conversation you had with someone you loved. In a block universe, your childhood sits as firmly in space-time as the chair you're in now. The page doesn't smudge. We're the ones moving our eyes across it, bound to a biological arrow that only reads left to right. Start with memory. Neuroscience treats memory as reconstruction, not playback. Each recall is a rebuild. Neurons refire, context tilts the story, emotion edits the emphasis. In physics terms, that makes sense. The past event is fixed in the block. Your brain's present state is a local, noisy process writing a new record about an old coordinate. When you remember, you're not reaching back. You're laying down a fresh trace now that points to a fixed point then. That's why new information can feel like it changes the past. It doesn't. It changes the model you hold in the present. A diagnosis reframes an argument from years ago. A letter turns a villain into a friend in disguise. Your experience of the past shifts because your current relation to that event shifts. The event's coordinates don't move. Your relation to them does. Identity rides on those relations. If the block is real, who you are isn't a single dot. It's your entire world line, the thread that runs through every moment where your brain holds continuity. Each decision, each habit, each promise is a point on that thread. You don't cause your future from outside the block. Your future includes the causes you become. Determinism doesn't delete agency. It locates it. Your choices are real at the points where they happen, with consequences drawn both ways along the web. That includes you. Here's where grief enters. The person you lost hasn't vanished from space-time. They're absent from your current slice. That sounds like a cold comfort until you sit with the structure. Every laugh, every quiet car ride, every small ritual is there as securely as sunrise. You can't step back to it. Biology and thermodynamics forbid that travel, but the fixity cuts both ways. The fear that the past will blur into nothing is misplaced. In the block, those coordinates don't decay. What fades is access, not existence. And yet the ache is real, because experience is local. The brain's arrow moves forward. Attachment is an ongoing relation, not just a stack of static points. A block universe doesn't grant reunion any more than presentism does. It gives a different kind of solace. The certainty that what mattered isn't at risk of unraveling into less real, simply because it's earlier. Reality isn't rationed. Earlier isn't weaker. There's a practical angle. Grief therapy often leans on reconsolidation, retrieving a memory and carefully rewriting its emotional weight. That's not erasing the past. That's shaping the present relation to a fixed event. In quantum language we've already used, it's like post-selection on meaning. You can't move the pixel, but you can change the subset it belongs to, the network of associations, the story it sits inside. The brain is a pattern engine. It updates models to keep you moving. Identity, through crisis, works the same way. In a time-symmetric lens, your future commitments act as boundary conditions on your present. Decide you'll be the kind of person who calls back, who shows up, who forgives after being hurt, and that future fact narrows your current options. That's not mysticism, it's how goals work. You set a constraint at one end of the corridor, your steps today align to fit it. In a block framing, those steps and that goal coexist. From inside, it feels like you're aiming. From the page, it's one consistent path. Memory has a second edge. Distortion. Because recall rewrites, the stories we tell about the past can harden into fictions that serve the present. The block doesn't protect against that. It only says the event itself is what it was. Humility follows. Check records. Invite other witnesses. Compare notes. In physics, we learn to wait for joint measurements before calling a pattern real. In life, compare notes is the relational move that keeps us from drifting into self-serving edits. Now the hardest line. If the future already exists, where does hope live? It lives where all your experiences live, on your world line as you encounter what's on the page. Hope is a present tense relation to yet unseen coordinates. You don't
control the page from above. You write within it from within, and your writing is part of the page. That's not empty. It's the only kind of authorship we ever had. Grief, identity, memory, none of them get smaller under a block view. They get truer about what hurts and what helps. You can stop bargaining with a physics that won't bargain. You can honor the fact that the person is gone from here and still wholly real in the there you shared. You can build a future boundary, values, promises, plans that narrows the corridor in ways that make tomorrow bearable to meet. And when anniversaries come and the ache flares, there's one more honest comfort. In the same way an interference pattern only appears when you ask a joint question, love only looks like love when you read the whole relation. Your moments in theirs, your choices in theirs held together. That relation is part of the fabric. Fixed, not less, not gone, just out of reach from where you stand today. The brain's arrow, why we sense flow. We've been living in geometry and lab tricks. Now we need to talk about why none of that feels true when you close your eyes and count your heartbeat. The brain insists on a moving present. Past behind, future ahead. That sensation isn't a property of space-time. It's a feature of how a wet, energy-hungry organ keeps you alive under thermodynamic rules. Start with construction, not capture. Your brain doesn't record time like a camera. It constructs temporal order from fragments, sensory delays, predictive models, and memory reconstructions. Different circuits track different scales. Milliseconds in the brainstem and cerebellum for coordination, seconds to minutes in striatum and prefrontal loops for actions and working memory, longer spans in hippocampus and default mode regions for autobiographical time. None of those loops points an arrow by itself. The arrow appears because information flows one way in practice. We can write new records. We can't unwrite the world. Decoherence and entropy are not just physics news. They're the operating system of experience. The environment constantly measures you, scattering information in heat, photons, and chemical gradients. That leakage makes macroscopic processes sticky, hard to reverse. So the only reliable path for an organism is to model forward based on records pointing back. The brain is a forecasting engine. It minimizes surprise by predicting the next sensory tick and updating errors. Prediction turns future into a moving target, hence the feeling of flow. Now add memory's trick. Recall isn't playback, it's reconstruction. Every time you remember, you rebuild using current context and goals. That's why new facts can alter old stories without touching what happened. You're running a post-selection on meaning, not events. The block doesn't budge, the narrative does. The feeling of the past becoming clearer or darker comes from present neural work, not retrocausal edits. Attention shapes duration. Boredom stretches minutes because prediction errors are sparse, and timestamps accumulate slowly. Novelty compresses hours because the brain spends resources encoding new patterns and drops fine-grained timing. Emotion amplifies this. A surge of arousal packs the timeline with salient marks. Grief drags it because you're scanning the world for a missing relation, finding none, and looping predictions that never resolve. The river you feel is viscous because attention is. There's another asymmetry, agency. We treat the future as open because our control signals point that way. Motor plans project outward. Feedback comes back. You can change the next sentence you say. You can't change the one you said. That operational truth trains the brain to tag ahead as mutable and behind as fixed, even when physics shrugs. The sense of now is the narrow band where prediction meets confirmation and error correction bites. It feels thick when models are uncertain and thin when life is scripted. What about those hints of knowing before things happen? Mainstream psychology is tough on that romance. When experiments are rigorous, precognition evaporates into selection bias, expectancy effects, and memory's flexibility. The mind is built to find patterns and write coherent arcs. It will borrow from the future of your inference to tidy the past of your recall. That's not retrocausality. That's a narrative machine doing its job. Neural timekeeping is distributed, so the self stitches a single thread from asynchronous parts. Vision lags touch. Audition lags both, yet you experience a unified present. The brain solves this with temporal binding. It waits a beat, aligns inputs, and backdates consciousness by a sliver, so events feel simultaneous. That backdating is small, but it proves the point. The present is computed, not received. Flow is an algorithm. Thermodynamics supplies the deeper reason we don't remember tomorrow. The universe's low entropy past gives us a direction where records accumulate and can be read. Biological systems exploit that by burning free energy to maintain far from equilibrium order. Your sense of self is one of those orders, an ongoing project of model maintenance that only runs one way, because erasing records is costly and incomplete. You're riding the steepest descent of feasible updates. So does the brain's arrow make the block a cold abstraction? Only if you expect experience to mirror ontology. We don't feel space-time. We feel the work of staying coordinated inside it. The flow is real as experience and parochial as a local dialect. It's the organism's best hack for moving through a world where the laws are time-symmetric, but the boundary conditions aren't. That's the fit we needed. A fixed, four-dimensional story can house a mind that feels motion, loss, hope, and urgency. The brain writes forward because writing backward is thermodynamically expensive and informationally impossible. The page stands still, the reader moves, and the moving is us. Technologies that toy with time. While the brain is busy stitching a one-way thread, engineers are building devices that nibble at time's edges. Not DeLoreans, protocols that make causality feel negotiable inside protected boxes. They don't break the guardrails, no messages to last Tuesday, but they make a hard point visible. Order, information, and when can be engineered like any other resource. Start with quantum random access to order. The quantum switch lets two operations, A and B, happen in a superposition of A then B and B then A. Feed a control qubit that decides the order in a coherent way, and you can beat certain fixed order tasks, discriminating channels, improving communication complexity. Nothing moves backward. Yet the advantage comes from refusing to commit to a single timeline of steps. In a block-friendly read, you specify boundary conditions that include both orderings, and the joint history accommodates them. In practice, it's a lab table with interferometers and fiber loops. On paper, it's causality as a dial, not a wall. Now to quantum erasure's practical cousin, ghost imaging and sensing. You illuminate an object with one photon and detect its entangled partner elsewhere to reconstruct an image. The which path of information, where did the light actually interact, gets routed through correlations, not through a classical track. In some variants, you can decide after the light has hit the object which joint property you'll read out. Again, no pixel changes in the past, but your present choice selects which pattern becomes meaningful. Metrology steals this trick. By shaping when you ask a joint question, you squeeze more precision from fewer quanta. Meanwhile, quantum communication leans on indefinite order to fight noise. Protocols exist where two noisy channels, used in a coherent superposition of orders, transmit more information than either order alone would allow. Operationally, you've built a tiny arena where before and after can interfere, and the interference carries your message more safely. Philosophically, it's a memo. Causal order is not an inviolable background. It's an ingredient you can cook with. Computing reaches for similar tools: pre- and post-selection, time-symmetric bookends, power weird subroutines. Weak value amplification boosts tiny signals by conditioning on rare final outcomes, letting experiments detect minuscule effects without smashing the sample. The price is low success probability, but the payoff is a cleaner read when it lands. In a time-symmetric narrative, the post-selection behaves like a future boundary sharpening the middle. In the lab, it's a better dial on a faint knob. There's also talk of retrocausal sensing protocols, ideas where you arrange measurements so that later settings seem to return information about earlier states more efficiently than classical bounds suggest. They never send bits back, but they reshape the accounting. With entanglement and careful post-selection, you pull more meaning per probe. Call it time-aware design rather than time travel. Security benefits too. Device-independent quantum key distribution uses Bell violations, global constraints that defy local, forward-only recipes to certify secrecy without trusting the guts of your hardware. The certification doesn't rely on a story about signals. It relies on correlations that only a world with non-classical order can supply. In the block frame, you're exploiting the whole's consistency to get guarantees about the parts. Quantum memories add a different flavor. Controlled delays that hold states with coherence intact. They don't bend time, they create temporal buffers where you can align operations that would otherwise miss each other. Combine memories with entanglement swapping, and you build repeaters, networks that stitch distant events into a single, certified relationship. It's logistics for correlations, carefully arranged across space-time slices. Across the hall, thermodynamic tech is testing the arrow. Tiny engines and feedback daemons show how information can be traded for work and vice versa, clarifying why erasing records costs energy. These devices underscore why macroscopic retro games fail. The environment is a recorder you can't turn off. But at microscales, with isolation and feedback, you can bend the local flow just enough to expose the rules. Simulations of closed, time-like curves on quantum circuits push the boundaries of thought experiments. By enforcing self-consistency conditions on quad bits, Deutsch-style models, researchers map what time-looped computation would imply. The results are provocative. Apparent speedups, paradox resolution via fixed points. Are there real CTCs? No evidence. Are the simulations useful? Yes, because they stress test our causal intuitions and inspire error correction and algorithmic tricks that mimic try until consistent, without enabling signaling to the past. Here's the human moment at a bench. A researcher
toggles a control qubit and watches interference fringes sharpen in a protocol that shouldn't work as well in a single order. It feels like cheating. It isn't. It's design that respects the constraints of a time-symmetric law while exploiting the asymmetries of information processing. The block isn't undone, it's being used. What ties these technologies together is a simple discipline. Treat causality, order, and measurement as resources. Protect coherence, and you can superpose not just states, but structures, paths, orders, even questions. Then harvest the interference. Let decoherence in, and the world snaps back to the ordinary arrow. The trick isn't to beat time. It's to work with the whole script long enough to write smarter lines. The edge cases, black holes, wormholes, and horizons. While engineers toy with order on optical tables, nature runs the extreme cases at cosmic scale. Black holes and horizons don't break the rules, they expose them. If the universe is a block, horizons are edits in what any observer can access, and black holes are the densest footnotes in the book, where geometry and information argue loudly enough that you can hear them across light years. Start with an event horizon. It isn't a wall, it's a one-way boundary in space-time. Cross it, and every future-directed path goes deeper in. From far away, you never watch the fall finish. Light from the infaller redshifts, slows, fades. From the infaller's wristwatch, the crossing happens on schedule. Both stories live in the same block. Two world lines, two slices, one geometry. Time order depends on perspective, not on a universal clock. Now drop a quantum in. Hawking's calculation says horizons radiate. Pairs pop from vacuum. One falls, one escapes. Over ages, the black hole evaporates. That line raised a painful question. Where does the information go? If the radiation is featureless, quantum mechanics loses track of states. Non-unitary evolution. If it isn't, the horizon must encode correlations that leak out as subtle structure in the glow. In block terms, the whole evaporation history has to be consistent with quantum unitarity. You can't delete facts from the page. They must be smeared across it in ways no single late-time snapshot shows without the right joint question. This is where the firewall debate flared. If unitarity and no drama at the horizon can't both stand, something gives. Either the horizon is locally gentle, as general relativity swears, or it's a searing curtain that breaks entanglement to save information. The block view doesn't pick sides. It insists the final script be globally consistent. Smooth infall for local frames, correlations and radiation for distant frames, and no superluminal rescue. Newer ideas, complementarity, islands, the page curve, suggest the bookkeeping works out without burning the traveler. The radiation's entropy bends at the right time if you include island regions inside the whole as part of the exterior's quantum story. Translation. The portion of space-time that counts as outside for information can include pieces you'd have sworn were inside. It's a block-level rearrangement of what's counted in a joint relation, not a last-minute rewrite. Signals can't climb out, but correlations can straddle the boundary. Meanwhile, causality gets weird but not lawless near horizons. The partner of a Hawking photon behind the horizon and the photon outside share entanglement until later emissions and interactions reshuffle who's paired with whom. That reshuffling, monogamy of entanglement, drives the paradoxes. Again, a time-symmetric story helps. Fix early collapse and late evaporation, and you constrain which middle entanglements are allowed. No message escapes. Correlations do, encoded in the whole of the radiation over eons. Wormholes tempt the other direction. Shortcuts. Classical solutions allow bridges, Einstein-Rosen throats.
In their simplest form, they aren't traversable. The throat pinches too fast. Quantum matter with exotic stress can hold a tunnel open in models, but then causality alarms ring. Time machines breed paradox. Here the block flexes its muscles through consistency conditions. Deutsch-like analyses say if a loop exists, only fixed-point histories survive. More recent, traversable wormhole constructions in ad spacetime don't enable messages to your younger self. They rely on engineered couplings between two boundaries, think paired systems, so that what looks like a wormhole is just a controlled causal transfer that never breaks no signaling. In holographic dualities, a certain entanglement pattern maps to a geometric bridge. ER equals EPR. That slogan isn't a cheat code to yesterday. It's a dictionary entry. Correlations across the page can look like glued geometry when you read it in the right language. Cosmic horizons widen the lesson. Because the universe expands, distant regions slip beyond our light cone. Their present never intersects ours. Eternalism takes this calmly.
Those far slices exist as surely as your breakfast. You'll never swap photons, but the page holds both. Inflationary patches may bud off like seeds. Whether those branches are part of one wave function or separate pockets is a fight between cosmology and interpretation. Either way, horizons don't erase. They limit who can compare notes. Here's the human scene that makes it real. An astronomer watches a star skim a black hole, sees its light stretch into red, and knows two truths at once. The star's own clock keeps ticking. Her telescope will never catch the final plunge. She isn't wrong, she's local. The block tolerates both accounts because now is a relation, and horizons are holes in relations, not in reality. So the edge cases don't puncture our story, they punctuate it. Black holes force information to be global. Wormholes translate entanglement into geometry without breaking causality. Horizons don't remove events, they carve who gets to witness them. In every case, the guardrails hold. No signaling to the past, time-symmetric laws, arrows from entropy. The page is still there. We're still reading from one side. The meaning, living inside a four-dimensional story. So what do we do with a world that already is? Start with honesty. Your life isn't a cursor changing the page. It's the page that includes you changing. Agency lives where you stand. Choices are boundary conditions you become. Responsibility doesn't evaporate. It's anchored to your world line. Hope shifts from altering fate to committing to futures that shape the corridor you'll walk. Grief stops bargaining with physics and starts honoring relations that are fixed, real, and unreachable. Meaning comes from reading more of the book together, comparing notes, building wider relations, and choosing constraints that let better patterns exist. The past isn't gone. It's woven into a whole that includes you choosing. If this reframes time, keep going, subscribe, share, and watch the next chapter on how cosmology sets the arrow we feel.